let's take a bird's eye view of the process we just went through in transforming this equation. Since we were aiming for having a perfect square at the end on the right-hand side of the equation involving x and a constant, we knew that the initial constant we started out with couldn't be right. Since right now, we can't factor x squared minus 8x plus 15 to be in this form. That means we need a different constant attached to the two terms with x in them. So the first step was to get rid of the initial constant we had so that we could have a different constant on the end of the x squared minus 8x. We figured out the constant that belonged at the end of those two terms was 16. When we add 16 to this, we get the perfect square of a binomial. This process is called completing the square, since the constant that we add on over here ends up giving us a squared expression as our answer. Now, we don't technically have to move the 15 away from the right-hand side to do this, but I think that it makes dealing with these two terms on their own a little bit easier, since we don't have anything else to look at on the right side. So completing the square is a crucial part of transforming equations of parabolas from standard form into the form where we can see the vertex. Now that we understand how to complete the square and the importance of that technique in transforming equations from one form to another, I'd like you to rewrite the equation y equals x squared plus 5x plus 6 in the form that we've been talking about. Now, if your numbers get a little bit messy in here, don't worry. That doesn't mean you're doing the problem wrong. That often happens in math. So just go with it, and then at the end, you can always check your answer by plugging in points to the equation that you start with and the equation that you end with to make sure that they're the same.